Alright guys, our next video, part B of part 2 of graphing trig functions, we're going to talk about graphing tangent, okay? So just a reminder, in our part A video, we went through and graphed a transformed sine graph, okay? It was transformed in basically all four ways that a trig function could be transformed. There was a vertical shift and a vertical stretch slash amplitude change. There was a horizontal shift, and there was a b value that affected the period of the graph. Instead of 2 pi, the period of this graph was pi. Okay? We used the vertical shift and the vertical stretch, the a value, to get our y coordinates. We used the horizontal shift and the b value to get our x coordinates. And then we had to remember the shape of a general sine graph, which starts in the middle, goes up, middle, bottom, and back to the middle. Okay? All right, now we're going to take a look at this tangent graph here, okay? There's one main difference between the way we graph a transformed tangent function, especially the x values, and a transformed sine or cosine function, okay? So you don't have to have all four transformations. Really here, there's no change in a value, okay? The a value is just 1, so there's not going to be a stretch, if you will. There is a vertical shift, there is a horizontal shift, there is a b value of just 1. Okay, so there's no adjustment that will need to be made for the period. Before we get to this, let's go back. We made a little spot for us to talk about tangent, okay? So number 2, when we're graphing sine and cosine, use the period to find the end of our one cycle for sine and cosine, and really, we are adding the period to the quote-unquote starting point of the one cycle, okay? For tangent, it's going to be a little different, and here's why, okay? Let's go recap the parent function for tangent, okay? The 0 is not the starting point like sine and cosine. The 0 is actually the middle. So when we graphed the parent function for tangent, the 0 point was in the middle. And that's how the graph looked. Just a reminder, okay? Whereas in sine and cosine, the first or starting x-coordinate was 0, okay? And then what we did was we could add the period to get the ending point. Or we could, again, add the period to get the ending point, okay? The period of tangent is pi. If we start at 0 and we think, well, let's just do what we're doing for sine and cosine where we're adding the period, well, that would go way beyond the one cycle here, all right? For tangent, what we want to think of is tangent has a period of pi. If we're thinking of, quote-unquote, beginning with our 0, okay, then really what we're doing is, aren't we adding half the period to get to pi over 2, and then subtracting half the period to get to negative pi over 2. Okay? The period of the tangent graph, the general parent tangent graph, is pi. So if I asked you, all right, let's start in the middle of the room, and the room is a width of pi. All right, to give you a little bit of an analogy, this is something we do in the classroom a lot. Okay, you're in the middle of the room. Tangent is different than sine and cosine because 0 is in the quote-unquote middle of one cycle. And if you were in the middle of a room that was a width of pi, and I asked you how far was it to each wall, you would say, well, half of that. It would be pi over 2 that way and pi over 2 that way. Like if the wall was 10 feet wide and you were in the middle, it would be 5 feet from each wall. Okay? So let's keep that in mind when we look at graphing the tangent function on the backside. So for tangent, we're going to use adding half the period and subtracting half the period from the shifted 0 to find our starting point and ending point of one cycle. And now that we've done this, all of our beautiful notes on how to graph a transformed trig function are all on the same page. We've got the general shape here at the bottom of sine, cosine, and tangent. Okay, we've got our steps to find the three y values using the vertical stretch and shift. We've got our strategy to find the 5x values using our horizontal shift and our b value, which could affect the period. Okay, and then we fill in the graph using that shape. All right, let's do that with our tangent graph here. Okay, let's state what the transformations are here. So this d value here, this is going to be a vertical shift, and this is going to be down 2. This minus pi, that's our c value, that's going to be a horizontal shift, and that's going to be to the right pi. Okay. So we always shift the 0 point. If we're shifting a 0, the point that is traditionally at 0 in the parent function, to the right pi, well, it will now be at pi. The main difference between sine, cosine, and tangent graphs is that when we shift the 0, this is the mid x value. It is not the starting or ending point of the one cycle that we traditionally graph. It's the middle. Okay? Just like our analogy of being in the middle of the room on, just a minute ago. Okay? The tradition, I guess we should probably graph the y coordinates for the y values first, since that's what we talked about. So let's deal with that. There's a vertical shift of down 2. Normally our parent function has y values of 1, 0, and -1. Let's shift all those down 2. There's no vertical stretch, so we'll just be at -2, -1, and -3. The a value of 1 means that from the middle to the top or bottom y value should be a distance of 1. Okay, so we're going to be below the x-axis here. All right. Most importantly, and tougher, is to find the x values. For tangent, which this is a tangent graph, we just talked about, we shifted our 0 point. It is now at pi. That's our middle x value. Our notes say, and we just talked about the reasoning, we're going to add half the period and subtract half the period to get our start and end points of that one cycle. All right. Tangent, its parent function period is pi. Okay. There is no b value. So the period would be pi over b, or in this case pi over 1. There's no change in the period of this function to the parent function for tangent. All right. So what we're going to do, we're going to add half the period, or pi over 2. Pi plus pi over 2 is 3 pi over 2. Pi minus pi over 2 is pi over 2. Okay, you guys will start to get a little better with the adding and the subtracting of fractions from way back in the day. Take the averages here. Okay. I'll give you a nice easy way to figure out if you're right with your x values. If we turned all of these into a denominator of 4, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. The numerators go in order perfectly spaced. 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. We've got our x values, we've got our y values. Let's just remember the shape of the tangent graph. It has an asymptote at the quote-unquote start and end of one cycle. And then we're going bottom to top. So the bottom y value, the middle y value, the top y value. And that is the graph of tangent. Excuse me. If we asked you for the amplitude, we did. There is none. Amplitude is only for sine and cosine graphs. The domain and range. Let's do the range because it's easy. Negative infinity to positive infinity, as you see the arrows here. The domain we touched on briefly in part 1. Okay. When a cyclical graph, a graph that will repeat, this graph will keep repeating every pi units. It'll repeat and it'll repeat and it'll repeat. When a cyclical graph has asymptotes, Okay, here's how we do that. We're going to say that x is in the set of all real numbers such that x is not, this is such that, x is not equal to pi over 2. So x is defined for all real numbers except x can't equal pi over 2. So basically we're just picking out one asymptote. We could have even used 3 pi over 2 here. Plus the distance between the asymptotes. That should match up with the period of your tangent graph times k, where k is an integer. We could put brackets around these. Okay. This means x can be any real number such that, or except, x can't equal, obviously, one of these asymptotes, or any x value adding pi, however many times. This could be pi, k could be 2, k could be 3. If we add 3 pi, if we had 4 pi, if we had 5 pi, if we have negative 3 pi, negative 5 pi, we will hit every single asymptote in the cyclical graph. Okay? So if you want a more formulaic way to find the domain, x cannot equal. You can pick the x value of any asymptote that you see on your graph, and then the coefficient of k will be the distance between asymptotes. In the case of tangent, that would always be the period of the graph. All right? And we are done learning how to graph tangent. Remember, the difference between tangent and sine and cosine is that when we shift our 0, we have the middle of our 5x values. And we have to go half the period to the right and half the period to the left to find our starting and ending x values of that one cycle.